in this tutorial presented by the Education Unit of EXCELIMKA Nigeria Limited. In this tutorial, EXCELIMKA presents Adejo teaching indices.
What's good, people? Adejo. That's actually Ibrahim Adejo, Certified SAP Solution Consultant, SAP Systems Applications and Product in Data Processing. Specialization, Advanced Business Application Programming in areas of Human Capital Management, Sales and Distribution, Financial Accounting and Controlling, Materials Management, Oil and Gas Secondary Distribution. I can actually do a couple more things like solving mathematics because I have a degree in Mathematics and Computer Science from the Federal University of Technology, Minna. Okay, in our previous videos we outlined these lesson objectives. We explained the meaning of indices to the letter. We stated the laws of indices. If you don't know this by now, you can watch our videos on YouTube. Give us a thumb up if you like this video. In this tutorial, which is actually our third indices tutorial, we shall be looking at operation involving index number. In operations involving index numbers, we shall focus our attention on expression in index form. Remember, we also have equation in index form, which we call exponential equation. This we shall look at in our subsequent video. Remember these laws of indices as explained in our previous video. They are not in any particular order, so you are not advised to commit these laws in any particular order to memory. Numbering, as used in our previous video, were for the purpose of illustration. So we look at this example. Evaluate 3a raised to power 2 multiplied by 5a all in bracket raised to power minus 2. Solution: 3a raised to power 2 multiplied by 5a in bracket raised to power minus 2 is equal to 3a raised to power 2 multiplied by 1 all over 5a raised to power 2. Remember our negative power law, which says that a raised to power minus n is equal to 1 all over a raised to power n. So applying that to 5a in bracket all raised to power minus 2, we have this equivalent transformation, 1 all over 5a raised to power 2. So this equal to 3a raised to power 2 all over 5 raised to power 1 a raised to power 1 in bracket all raised to power 2. Remember, we said whenever a number or variable is not having an index, by default the index is 1. So for 5 the index is 1, and for a the index is 1. Reason why we have 5 raised to power 1 a raised to power 1 all raised to power 2 at the denominator. So 3a raised to power 2 all over 5 raised to power 1 a raised to power 1 all raised to power 2 is equal to 3a raised to power 2 all over 5 raised to power 1 multiplied by 2 a raised to power 1 multiplied by 2. Remember, we have applied our power law. Our power law, as we can see here, it says that power outside for an index number multiply the index inside the bracket. Reason why a raised to power m all raised to power n is equal to a raised to power mn. So we have applied the power law to the denominator. In this case, 5 raised to power 1 all raised to power 2 becomes 5 raised to power 1 multiplied by 2. In like manner, a raised to power 1 all raised to power 2 become a raised to power 1 multiplied by 2. This follows from the application of power law to the denominators, as we can see here. So this is equal to 3a raised to power 2 all over 5 raised to power 2 a raised to power 2, because 1 multiplied by 2 is 2. Similarly, 1 multiplied by 2 for base a is 2. Remember, we say 1 is an identity element. In multiplication, it multiplies any number or variable without changing it. So a raised to power 2 are common in numerator and denominator, so we strike them out. So this is equal to 3 all over 5 raised to power 2. 5 raised to power 2, as seen in the denominator here, means the number of times you can use 5 in a multiplication operation with itself is 2 times. So this equal to 3 all over 25, because 5 times 5 is 25. Alternatively, when we have 3a raised to power 2 multiplied by 5a in bracket all raised to power minus 2, we can transform it in this way. 3a raised to power 2 multiplied by 5 raised to power 1 a raised to power 1, all in bracket is raised to power minus 2. Remember our power law. In our previous solution, we have applied the negative power law, but this time we are going to apply the power law, positive power, simply put, to solving this problem. So power outside multiplies power inside. That's what this law is telling us. So this becomes 3a raised to power 2 multiplied by 5 raised to power minus 2 a raised to power minus 2. This follows from the fact that 1 is the index for 5. It multiplies minus 2 and we have minus 2. 1 is an identity element. Remember, it multiplies any number without changing it. In the case of base A, 1 is the index. It multiplies the power outside. We still have minus 2. This is equal to the numeric entity here, 3 and 5 raised to power minus 2. So we group them together. Because they are not identical, we cannot apply the multiplication law. The base 3 and 5 are not identical. So we have 3 multiplied by 5 raised to power minus 2, and applying the grouping law to a raised to power 2, a raised to power minus 2, which are variable. We have a raised to power 2 multiplied by a raised to power minus 2. So this equal to 3 multiplied by 1 all over 5 raised to power 2 in bracket. Remember, 5 raised to power minus 2 attracts the negative power law, as we can see here. A raised to power minus n is the reciprocal of a raised to power n. In the same vein, 5 raised to power minus 2 is the reciprocal of 5 raised to power 2. And we have applied our multiplication law, as we can see here, to a raised to power 2 multiplied by a raised to power minus 2. The base a are identical. We take one of the base. So we apply addition to the indices because multiplication operation is involved. So we have 2 plus, the addition sign here follows from the fact that multiplication operation is involved. Then minus 2, which is the negative index that we have here. So this equal to 3 all over 5 raised to power 2, because 3 multiplied by 1. Remember, numerator multiplies numerator. Denominator multiplies denominator. So the denominator for 3 here, which is not available, is by default 1. So 3 multiplied by 1, we have 3. 1 multiplied by 5 raised to power 2, we have 5 raised to power 2. And we have also applied our multiplication law to this. A raised to power 2 plus minus 2. It is very important to note that in arithmetic operation, addition operates on addition to give addition. Addition operates on subtraction, result in subtraction operator. Subtraction operates on addition, result in subtraction operator. Subtraction operates on subtraction, result in addition operation. This can be simply memorized as when the signs are the same, the resulting operation is an addition operation. When the signs are different, as we can see here, the resulting operation is a subtraction operation. Here the signs are the same, so the resulting operation is an addition operation. So 2 plus minus 2, addition acts upon subtraction. The two signs are different, so our resulting operation will be a subtraction operation. Reason why we have a raised to power 2 minus 2. So this equal to 3 all over 25 a raised to power 0, since 2 subtract 2 will give us 0. So this equal to 3 all over 25 multiplied by 1. Remember, any number raised to power 0, as in this case a raised to power 0, will be 1. So this is equal to 3 all over 25, since 3 multiplies 1 will give us 3 at the numerator. 25 multiplies 1 at the denominator here. Remember, we say when any number or variable is not having a denominator, the default denominator is 1. So 25 multiplied by 1 is 25. In our second example, we simplify 6x raised to power 3 divided by 8x raised to power 2 in bracket raised to power minus 3. Solution. This equal to 6x raised to power 3 divided by 1 all over 8x raised to power 2 all in bracket raised to power of 3. This follows from the fact that 8x raised to power 2 all raised to power minus 3 can be transformed to 1 all over 8x raised to power 2 all in bracket raised to power 3. Remember our negative power law. A raised to power minus n is equal to the reciprocal of an. So 8x raised to power 2, remember the base entity are numbers and variable. So the base all raised to power minus 3 will give us the reciprocal of the base all raised to power 3. So this is equal to 6x raised to power 3 divided by 1 all over 8 raised to power 1 multiplied by 3 on the index, x raised to power 2 multiplied by 3. This is so because when we look at the power law, as we can see here, positive power in this case, power outside multiplies the power inside. So the power for 8 here is 1. Remember, there is no index, so the default index is 1. So 8 raised to power 1 multiplied by 3. Power inside multiplies power outside. We have 8 raised to power 1 multiplied by 3. Similarly, x, in this case, the index is 2. So it's going to be x raised to power 2 multiplied by 3. Reason why we have s raised to power 2 multiplied by 3 at the denominator here. So this is equal to 6x raised to power 3. Remember, first thing first. So we bring the 6x raised to power 3 down first. Divide by 1 all over 8 raised to power 3 x raised to power 6. Here, 1 multiplied by 3 gives us 3. 2 multiplied by 3 gives us 6. Reason why we have 1 all over 8 raised to power 3 x raised to power 6. So this equal to 6x raised to power 3 multiplied by 8 raised to power 3 x raised to power 6 all over 1. If you look at what the division sign on the right hand side have been transformed to multiplication, as we can see here. So whenever a division sign is changed to a multiplication sign, we have an inversion of the next entity after the division operator. So 1 all over 8 raised to power 3 x raised to power 6 has been inverted to 8 raised to power 3 x raised to power 6 over 1. That is, when division sign is changed to multiplication, the next entity after the division operator is reversed. That is, numerator becomes denominator on the other side and denominator becomes numerator. So this is equal to 6 multiplied by 8 raised to power 3. 6 and 8 are numeric and their base are not identical. We group the numeric entity together and also group the alphabetic entity together. So we have x raised to power 3 multiplied by x raised to power 6, which we have in this bracket. The use of bracket in mathematics is very important for the purpose of grouping of terms together or entity that are like in terms of numbers and variable. So this equal to 6 multiplied by 512 all in bracket x raised to power 3 plus 6. Remember, 6 multiplied by 8 raised to power 3. Here, 8 raised to power 3 implies 8 using multiplication operation 3 times. 8 times 8 times 8 gives 512. Here we have a multiplication operation on our hand. The base are identical. We take one of the x and we add the indices 3 plus 6. So this equal to 3072 x raised to power 9. 6 multiplied by 512 gives 3072. X raised to power 3 plus 6 gives x raised to power 9. Alternatively, when we have 6x raised to power 3 divided by 8x raised to power 2 all in bracket raised to power minus 3, we can approach it from this perspective. First thing first, as we always said, 6x raised to power minus 3 divided by 8 raised to power 1 multiplied by minus 3 in bracket x raised to power 2 multiplied by minus 3 in bracket. Remember our power laws. In our previous example, we applied the negative power law. It says a raised to power minus n is the reciprocal of a raised to power n. In this case, we have applied the positive power law. Power outside the bracket multiplies power inside the bracket. So minus 3 is outside the bracket. It multiplies all the power inside the bracket. Remember, the power of 8 in this case is 1. The default index for number of variable when there is no index is 1. So 1 multiplied by minus 3, we have 8 raised to power 1 multiplied by minus 3. Similarly, 2 multiplied by minus 3, we have x raised to power 2 multiplied by minus 3. This equal to 6x raised to power 3 divided by 8 raised to power minus 3 x raised to power minus 6. That is 1 multiplied by minus 3. 1 is an identity element. It multiplies any entity without changing it. So 8 raised to power minus 3 follows from the fact that 1 multiplied by minus 3 is minus 3. 2 multiplied by minus 3 gives x raised to power minus 6. Remember, for some of us that find it difficult to operate with sign, the sign of a number of variable whenever it is invisible is positive. So 2 is positive here. Addition upon subtraction, as we said before, is subtraction. So 2 multiplied by 3 gives 6. So reason why we have minus 6. This is equal to 6 divided by 8 raised to power minus 3. Remember, we are grouping numbers separately and variables separately. We have 6 divided by 8 raised to power minus 3, which follows from the fact that 6 divided 8 raised to power minus 3 here. And x raised to power 3 divided by x raised to power minus 6. The grouping principle also applies to x raised to power 3 divided by x raised to power minus 6. So this equal to 6 divided by 1 all over 8 raised to power 3. Remember, we have applied our negative power law here. A raised to power minus n is a reciprocal of a raised to power n. So 8 raised to power minus 3 is a reciprocal of 8 raised to power 3. And x raised to power 3 minus 6 follows from the fact that we are applying division law, which is our second law, as we can see here, to s raised to power 3 divided by s raised to power 6. So x and x are identical. We take one of the base. We apply subtraction to the indices since the division operation is involved. Our second law says division operation involves subtraction of indices for index number with identical base. So 3 minus, as a result of the division operation, minus 6, which is the minus 6 we have here. So this equal to 6 multiplied by 8 raised to power 3 over 1. Remember, we say when division operation is changed to multiplication operation, the next number of variable after the division sign will be inverted. That is, the denominator becomes the numerator and the numerator becomes the denominator. So x raised to power 3 minus 6 become x raised to power 3 plus 6. I believe you can now guess why we have an addition operation here. Subtraction operates on subtraction. Whenever the signs are the same, the resulting operation is an addition operation, as we can see here. Whenever the signs are the same, negative, negative, the resulting operator is addition. Positive, positive, the resulting operator is addition. So 3 minus 6 will give 3 plus 6. So this is equal to 6 multiplied by 8 raised to power 3. Remember, 8 raised to power 3 over 1. The denominator is 1. So it's as good as writing 8 raised to power 3 without the denominator. We do this because 6 is not having a denominator. We can express 8 raised to power 3 in the form without a denominator by removing 1. If it is any number other than 1, you cannot remove the denominator. Take note. And x raised to power 3 plus 6 become x raised to power 9. Is equal to 6 multiplied by 512. 512 is as a result of the fact that 8 raised to power 3 means 8 using multiplication operation with itself 3 times. 8 times 8 times 8, which is 512. And x raised to power 9, which is what we have here. So this equal to 3072 x raised to power 9. 3072 is as a result of the multiplication of 6 by 512. So we can see that this answer is the same as what we have in our previous solution by applying a different techniques. So we can say at this point that there are many ways to solving a mathematical problem. All you need to do is to ensure that the mathematical rules are followed meticulously. In our third example, we simplify 36 raised to power 1 over 2 multiplied by 64 raised to power minus 1 over 2 multiplied by 5 raised to power 0. As we can see here, we have fractional indices. Solution. Remember our laws of indices. By now, you should have known how to use it, when to use it, and where to use it. They are not to be committed to memory in any particular set order. Remember, in a particular mathematical solution, we can use one or more of this law to arrive at our solution. So, 36 raised to power 1 over 2 multiplied by 64 raised to power minus 1 over 2 multiplied by 5 raised to power 0 is equal to the second root of 36 all raised to power 1 multiplied by 1 all over 64 all raised to power 1 over 2 multiplied by 5 raised to power 0. So as we can see here, 36 raised to power 1 over 2 has been transformed by the application of our fractional power law, because the index involved here is a fraction. So if we compare with the generic form of the fractional power law, the base here is 36, the index m over n is 1 over 2. So we apply this transformation, the denominator root of the base all raised to the power of numerator. So that's what we have applied to arrive at this. The denominator is 2 of the fraction. So the second root of the base 36 all raised to the power of the numerator, which is 1. Also, 64 raised to power minus 1 over 2 has been transformed to 1 all over 64 all raised to power 2. So if you look at this transformation, we have applied the negative power law, which says that a raised to power minus n is equal to 1 all over reciprocal of a raised to power n. So 64 raised to power minus 1 over 2 is equal to 1 all over the reciprocal of 64 raised to power 1 over 2. So this is equal to the second root of 36 all raised to power 1 can be expressed as the square root of 36. This is as good as saying the square root of any number is the same as the second root of that number. So in mathematics, whenever it is the second root, it is not shown, but numbers from 3 and above are shown. For example, the cube root of any number will have to be shown as 3. So second root of 36 is as good as saying the square root of 36. All raised to power 1. Remember, we say when the index is 1, it is immaterial, we can remove it. So we have removed the power of 1 here. Multiply by 1 all over the square root of 64. Remember, we have applied our fractional power law here, which is the denominator root of the base all raised to the power of the numerator. But the denominator root, that means the second root, which is as good as saying the square root of 64 all raised to power 1. Power 1 is negligible, we can remove it. Multiply by 1. Remember, 5 raised to power 0 is 1. This follows from the fact that a raised to power 0 is 1. So this is equal to 6. The second root of 36 means what is that number you multiply by itself 2 times to give 36, which is 6. Multiply by 1 over 8. The square root of 64 is as good as saying the second root of 64. It means what is that number you multiply by itself 2 times to get 64? This number is 8. So multiply by 1, which is the one that we have. So this equal to 6 all over 8. This is because denominator and numerator are involved here. 6 is the numerator. The denominator for 6 by default is 1. We have 1 as the numerator here, 8 as the denominator here. Here the numerator is 1, the denominator is 1. So 6 multiplied by 1 multiplied by 1 is the same as 6. 1, which is the denominator here, multiplied by 8 multiplied by 1 is the same as 8. So this is equal to 3 over 4. This is so because 2 divide 6 is 3 and 2 divide 8 is 4. We are using 2 to do this division because it It is the common factor for the numerator and the denominator. 3 can divide 6, but it cannot divide 8. So therefore, 2 can divide 6 and it can divide 8. Reason why we have used 2 to divide 6 to get 3 and 2 to divide 8 to get 4. I believe we have been able to make you understand that there are many approaches to solving mathematical problems. So in our next tutorial, we shall be looking at operation involving index number with focus on exponential equation.
Thank you for watching this tutorial. You can play this video over and over until the techniques involved become your approach to solving mathematical problems in index form.